Okay, let's start Lab 8 for AgEcon 305, titled Substitution Elasticity and Prices. Our current topic in the course is value chain and the relationship between successive levels in the ag to food value chain. And our specific focus in this lab is going to be on substitution possibilities. So when we think about the value chain, we think about the idea that one level of production or one output is also the input for some higher level production process. Okay, that's what we mean by value chain. Things are passed up, so there's a production component that is the output for one decision maker or one firm that gets passed along to be used as an input. That's a key finding, a key point of analysis in agriculture. So it's also key for understanding price relationships. So what we're going to do is think about that. How do markets that are related by these direct purchases in the value chain impact one another? How does an agriculture output, how is its price affected by the final retail level? That's what we've been talking about in the lecture. And we're going to shift in this lab to talk about how do the agriculture input markets, the inputs used by production agriculture, how might they be affected? Purchase of inputs in general, for whatever level you're talking about in the value chain, is driven by two factors. The first and sort of simplest one to consider is expansion. The idea that if demand for my output goes up, then it should cause me to need additional inputs, right? The way to expand is to get additional inputs. But the other thing that can happen is that the price in the input markets can change, right? So I use diesel to produce a crop. Demand and supply in oil markets causes it to be more expensive. And do I substitute away now from energy or diesel as an input by reducing the number of tillage trips or the number of trips I make across a field? Maybe go to a reduced tillage or something like that, and shift to chemical control instead of a more expensive tillage technique. So these are the things that we talk about in price terms, the substitution possibilities, and they work together. And so we should be able to find both impacts, and we should have to account for both impacts, and we'll see how we do that in our model setup today. When looking at related markets, we've been focused on farm to retail. It's a simplified example of the value chain. It's very useful for understanding that, and its primary use is looking at what is concentration like in agribusiness and retail food sales, and how does that affect farms. We had to make some assumptions. We assumed that there was this fixed cost margin. So the things that aren't agriculture, the things that aren't the commodity output of farms, sort of the crop or the ag component, those non-ag inputs come at a fixed cost. So there's like a bill that you pay, and you receive this mix of inputs to combine with the ag input, and you get the food or the retail product. So that gives us, that simplifying assumption did a lot for us. It gave us the opportunity to relate the farm output market and the retail output market using a single primary supply and primary demand curve. So the whole point of that was to be able to put in one graph the supply versus demand and model that, and we'll continue working through that in class. The reason we were able to use those primary curves is because we said the derived demand and supply curves were controlled by that marketing margin. So as we continue looking at that, you'll see that we treat it like a tax wedge, and it becomes a simplified approach that lets us continue to use a model, equilibrium model of supply and demand that we've been using all along. But it comes with some assumptions those are costly assumptions. We have to be careful. We have to assume that there's a constant price for all the non-agricultural inputs, and we have to assume there's no substitution between ag and non-ag inputs at retail, which may be these may be restrictive. Anyway, so we will continue to look at that in lecture and follow-up classes, but the thing we want to think about today is the specific role of substitution. Okay, so we're going to expansion is one way that we require more input, but the substitution role is really the price-driven role, and that's what we're going to talk about. So our new problem is the farm output market and how to relate it to farm inputs. So we're going to make this simple too. We're going to say there are two farm inputs. There's land and there's all other inputs. So we have a lab handout this week, and it's fairly extensive, so I probably will try to keep this video a little shorter than some of the others have been, so because the details are written out. But that lab handout goes through this equilibrium displacement model approach to modeling these farm markets, and really the relationship between farm outputs and those two inputs. Of course, the critical question we're going to think about today in this this lab is, how do land prices adjust when the farm market, the farm product market changes? Okay, so the idea here is that agriculture could have a very low supply response or a low supply elasticity, and that could be traced back to the requirements of land being used in production and land being in a relatively fixed supply. And one of the things that is tracked along with in agriculture and ag prices, one of the things that's tracked along with farm and retail costs and what those spreads are land prices, for a number of reasons. One is that's how we think about wealth in some degree in agriculture. As land prices appreciate or go up, the amortization, the sort of long run sale value goes up more. But it's also a big cost. The opportunity cost or the rental factor attached to land, whether you own it or not, can be a significant piece of farm production costs. Okay, so in our lab, I'm just going to highlight some different pieces of the lab handout. So if you want, you could pause this, find these sections and listen to me go through them, or you can read until you get to that part. It's just however you want to work back and forth between these. And of course, if the lab handout seems complete enough for you, then there's probably a point that you could just read and then come back to this video for the experiments. So just obviously, however you want to interact with the material. I'm trying to cover it all in a couple of ways here. So there's 3 tasks: read this handout, watch the lab video, and then of course we'll have a quiz at the end where you just make note of the different experiments and answer a couple of questions. So so we have this model that's explained in the handout, and here's the table that gives all the variables and parameters. So we have 3 markets that we have to think about simultaneously. One is the farm output market, and you could think of this farm good as being corn, you could think of it as soybeans, or you could think of it as just agriculture's output, the sort of common representative agriculture output. Specifically, I guess, because we're using land as an input, a crop production. So that I mean, however you want to think about that, but these are the variables that relate to the sort of crop output. So we have the quantity, demand. And they're all percentage changes. So this is an equilibrium displacement model to simplify this and to get the equation small and to get rid of all the intercepts, basically. We convert this to percentage changes, so we have all percentage change variables in this column, and we have the percentage change in the demand for farm output, percentage change in the supply of farm output, and the market price, percentage change in the market price for farm output. Okay, so those are all collected there. And now we have to deal with our two input markets. So these superscripts are F for farm, L for land, and N for non-land. Okay, and so Q is going to be the output market with P for the prices, and X will be the input market, and R for rental rates or input costs, however you want to think about that. So these are all parallel then. So we have a quantity demanded first, quantity supplied, and then the price. So this is the market prices here. So that means this is the percentage change in the demand for land, percentage change in the supply of land, and the market price or the market rental rate for land. Percentage change in the demand for non-land inputs, supply of non-land inputs, and the market price. Okay, so those are our variables. We have to get the corresponding parameters or coefficients, if you will, that go with those, and we need this many. We need 1, 2, 4, 6. So we need an elasticity of demand for farm output, and instead of having a supply elasticity or demand elasticities for inputs, we are going to make use of something called the substitution elasticity, and it's an elasticity of substitution between land and non-land. And if you want a formal definition, we'll have one in class, but it's the it's basically, how does the ratio of inputs change? How does the land to non-land ratio of input use change as the price ratio between land and non-land adjust? Okay, so the substitution elasticity is sort of a complex concept, but you'll see that it makes for a very simple write-up when we write these equations. The other part here is the cost shares. So how important in farm product costs are land versus non-land, and then of course there is a market for land and a market for the non-land input, and so those need supply elasticities. If you look here, we have 9 unknown variables. That means we need 9 equations. The parameters basically define demand and supply response in all 3 markets, and we need a couple of different parts. So if we're going to use the substitution elasticities, it means we need also the cost share of inputs. So essentially 1, 2, 3 pieces here work together to give you the demand elasticities for the inputs, but also to give you the supply elasticity. So these 3 things give you 3 parameters that we would think about. That being the supply elasticity for ag output and the demand elasticities for ag inputs, or inputs into the agricultural production. And that's what this is saying down here. Note that the supply elasticity for agriculture and demand elasticities are being determined. We could calculate those, but the way we're doing it here is the substitution parameter and the cost shares. Okay, so this is our big equation setup. So we said we had 9 variables. Well, these are the 9 equations that we'll solve to give those. Start at the top. We have a farm demand equation. So this is the farm outputs demand equation. The price times the elasticity of demand. That works out simply and makes sense. 2 and 3 are the input demand equations. So we go from the output demand to the farm input demand, and it gets, this is the part where you have to stop, think about what we have. So we have the percentage change in the land demand, and then we have a term here and a second term here. Well, we said that there was an expansion component to input demand. Okay, and so this second term here is just the expansion component. It says that if nothing else changes and I increase the supply, right, in equilibrium, increase the supply of farm output, that's what this variable is, the percentage change in the supply of farm output. If nothing else adjusts, then I should be required to expand my use of land in production. And then we get that same expansion factor here for non-land inputs. Okay, so the second term out here is that expansion factor that we started talking about. It says if you're going to scale up production and sales of the agricultural output, then you should, if nothing else changes, all else constant, the adjustment needed for input demand for land and non-land should be proportional. So those percentage changes would be the same. The part that we have to add in the first term is the substitution component. So this bracket multiplied by the substitution elasticity, the bracketed term times substitution elasticity, is the substitution component. Okay, and so this is so sigma Ln is the substitution elasticity between land and non-land inputs in ag production. It appears in both equations. It's the same parameter. And it gets multiplied by two prices. So the output price and the specific input price. So in the land equation, it's the output price, subtract off the input price for land. And here it's the output price for ag minus the input price for non-land. And I'm going to skip ahead one slide just to show you why that is. Why do we end up with those two prices in there? Well, it's because this is a homogeneous system, and we need to use the price ratio. So when we're talking about substitution elasticities, we have to talk about some ratio of prices, because it's the substitution elasticity is defined as the percentage change in the input ratio relative to the percentage change in some price ratio. And so we can get away with doing it as the output price divided by the input price, so P being a level of the input of the output price, R being a level of the input price. And if you go through the conversion process from going from levels, the actual price of these two things, you do what we call, you first take the logarithm and then you take a derivative, and that's the process from going from these kind of variables to percentage change variables. And so that's what's going on here. So you can see that what's going on is I'm taking the log of that price ratio, and if you write the logarithm like this, well, it's the same thing as writing this difference in these two logarithms, so that when you take a derivative, this is the percentage change in the output price, this is the percentage change in the input price. Okay, and so that's where these bracketed terms are coming from here. Once we decide we're going to use the substitution elasticity, we need to use a ratio of two prices for that to work on. And once we convert to percentage changes, that ratio gets converted to this difference in the percentage changes. Okay, and so that's a parallel thing. You don't have to know that or be able to reproduce it. It's just when I write equations like this, because I'm going to have to for us to deal with these substitution elasticities, you need to understand that this is the format that we're going to be using. Okay, so if we're using substitution elasticities to deal with factor demands, then those demands combine in a specific way to give us the output supply change. And so one of the ways that we can handle the output supply equation is to not write it as sort of the normal price times the supply elasticity, but we use something called the cost equation, the zero profits equation. And that says basically that farms, if we're going to assume competition at the farm output level, right, homogeneous products, there's lots of farms making corn, there are lots of farms making ag outputs, then they should earn zero net economic profit. Right? Everything should be paid its opportunity cost, but once you pay out the management, you pay out the land rents for any owned factors of production, those profits should be zero. And so that's what this equation is. And it says that if you take the cost share times the land rent and the cost share, that's what these are, SL and SN are cost shares in production. If you take those cost shares multiplied by the change in the land price and the change in the non-land price, that should give you the total change in the output price. Okay, and that's just a simplified version of the cost equation, right? So if the costs are going to adjust, if the cost of production adjusts, then the output price has to adjust to make up for that. And so that's what's going on here. So we're measuring the cost change component related to the changes in the non-land price and the land price, and we're saying that the output price has to adjust to take care of those. Here we have the land supply equations. So these eta parameters, eta L and eta N, those are just land supply elasticities or non-land supply elasticity. Okay, so these are just the change in the supply. Oops. This should be S and N. Sorry about that. So this should be the X, should be the percentage change in the supply of non-land inputs. And this should be the percentage change in the supply of land inputs. Sorry about that. So they depend on the price of land, the price of non-land. And then the last three equations are pretty simple. They just say that the supply, percentage change in the supply, needs to be equal to the percentage change in demand for land, for non-land, and for the farm output. So the markets all have to have these market clearing conditions. Okay, so that's the last three being market clearing conditions. Makes it a little simpler because now it's really just 6 equations, right, that need to be dealt with. And we could do that. We could set that up and solve all those. But there's actually a couple of other simplifying assumptions that are fairly common in agriculture, and that might make this model a little more easy to look at and give us some known results that will be useful for our experiments. So we're going to simplify this, and we're going to focus on just the substitution and the cost shares, because those are the drivers. Those are the things that we're using here. And so assumption 1, I'm going to say make the farm product demand exogenous. So I'm going to get rid of equation 1 and say that instead of, well, if you notice our equations, we don't have any shock variables here. And if you remember back to when we were doing equilibrium displacement models, I said you need a shock variable of some kind, either a shift to the supply or demand or a tax variable, something that you can exogenously change. Otherwise everything just stays at 0. There's no reason to adjust from the equilibrium. And so what we're going to do is we're going to make product demand, output demand exogenous. And so instead of dealing with equation 1, we're just going to get rid of it, and we'll just consider shifts to the demand for the agricultural output. Okay, so essentially we'll be making QDF an exogenous variable. And then of course the supply has to be equal to that, and it gets tied up in the expansion factor. We're going to make land supply perfectly inelastic. That means it's a fixed quantity. Okay, so we're going to say that when we go out and look at the land market, it doesn't matter how much more land we want, we can't get any more. Okay, so it's a fixed supply market, and that's what figure 1 gives you. And so this is what a fixed land quantity looks like. So X star is some fixed amount, equilibrium amount in fact, of land that gets supplied. And so as the demand for land changes, right, if it gets stronger, you'll see the land rents go up, but you won't see any increase in the land quantity. And then assumption C is given over here in figure 2, and that says make the non-land input supply perfectly elastic. So land was a fixed quantity, and for non-land we're going to say it's a fixed price. That's also incorrect, sorry. And so that's what this looks like. So it's a horizontal line like this at R star, and so there's a fixed price, an equilibrium price for non-land inputs, and you can buy as much as you want as long as you're willing to pay that price. Okay, and so this means that in our model, when we change the demand for ag output, we're going to see the price adjust for land inputs, and we're going to see the quantity adjust for non-land inputs. Okay, and so that's really what's going to drive this. So that'll give us a chance to look at substitution, how easy or how do we increase output by substituting non-land inputs. I guess you could think of them as yield increasing inputs. How do you try to get more on the fixed land base? And then how much pressure, how much push do you put on land prices and output prices, I guess, by extension, when you adjust the demand for ag outputs? Okay, what does our simplified model look like? Well, we get rid of the old equation 1 and the old market clearing equation for the quantities. Instead of having QF and QS and QD, we're just going to treat this and change it to Q prime, and that's just going to be our shock variable. Okay, so we have the demand for land, the demand for non-land, these are both inputs, and we have the substitution component, the substitution term right here between the bracket and the substitution elasticity for both of these. But the second term is just going to be the shock, right? So Q prime is just some shift to the demand for land that comes from the output market. Okay, and that'll be enough for us to deal with this and model this. All of our experiments are sort of technically, our experiment is going to be to shock output every time, and it's going to be about 1%. So we're going to leave that shock alone. What our experiments are really going to focus on are when this is shocked by 1%, how do adjustments in substitution possibilities in terms of the substitution elasticity or these cost shares cause prices to adjust? Okay, so under different conditions, how do we see the price relationships change? Okay, so we are to build this. It's a 7 equation model. And so the reason we did the lab we did last week was to get a better handle on how to write these matrix type equations. And so I built the spreadsheet for you. You can open it and see it right now, and I'm going to talk about it here. To make this matrix ready, remember we have first step is to put all the endogenous variables in their own terms and on the left hand side of the equation. So that means anything that was on the right hand side that's endogenous needs to be moved to the left hand side, and any multiplication times a bracketed term or whatever needs to be broken out, and so that's what's done here. So we had substitution elasticity times the output price, substitution elasticity times the input price, and we had those on the right hand side. So when we move those over, that's what this is. Okay, and so this term needs to be moved to the left hand side, so that puts a negative sign in front of the sigma ln, and then we need to use the distributive property and multiply this times PF and multiply it by RL, and that's what goes on to get these two equations. Remember, Q prime is now this output demand shock, so it's exogenous, we're going to leave it on the right hand side. Here we have the zero profit or the cost share equation, so all we need to do there is move these terms for the term involving the land price and the non-land price to the left hand side. Our simplifying assumption for the land market was fixed quantity of land. So this says the percentage change in the supply of land is equal to 0. You can't get more, okay? And so that controls the land supply, and then we'll control the non-land supply by saying the price can't change. So Rn, the rental rate or the return or market price of non-land inputs, has to be equal to 0. So that's the fixed non-land price equation. And then to get the market clearing equations in matrix format, we just subtract the demand. And so it says there's no, the surplus supply has to be 0, the surplus supply has to be 0. Okay, remember our matrix setup, and so when you go to the spreadsheet, you'll see that this is filled in. But we start with what we call the A matrix. It has 7 equations, the 7 equations we just looked at, and then it has 7 columns, 1 for each of the variables in the equations. So remember, we need a column for everything, and if a variable doesn't appear in one of the equations, like equation 7 does not have the market price for land in it, you just put a 0 in and fill that in, and then the matrix algebra technique will allow it to solve. Here's the spreadsheet model as it's filled in. So we have equation 1 through 7. We have the coefficients filled in here. You can see obviously lots of them are zeros, but that's what we need. Down here I have the parameters, so we have the land cost share assumption at 0.25. 1 minus that value gives you the non-land cost share. Here's our shock, the ag output change, and yeah, everything here is linked back. So I think I'll switch out to the spreadsheet now and show you what we have. Okay, so here's the spreadsheet model. Let me start with the parameters here. So the land cost share, I assume it's 0.25, and then if you look here for the non-land cost share, because there's only 2 inputs and the cost share, the total costs in share term has to be equal to 1, then we can just say the non-land cost share adjusts as we change the land cost share. So when you change these, you'll only be changing this value in B13. The substitution elasticity is given right here in B15, and so when you make adjustments to that, you can do it right here in that cell. So make it small or whatever. But everything starts from this sort of base case of a substitution elasticity of 1 and the land cost share of 0.25. And let's go with the ag output change. This is the value for Q prime right here. So I didn't write it like that, but that's what it is. So this is that right hand side variable, the exogenous variable, that's going to be equal to 1. So everything we do, we're going to say output gets shocked by 1%. Let's look at the price impacts. Okay, so let's go to our matrix. So if you look up here in the matrix, you'll see that this is actually a formula. Okay, so the matrix here is, some things are just 1, but this one is a 1 because the substitution elasticity is equal to 1. Okay, so if we come down here and change this to 2, you'll see that the coefficient in front of RL gets changed to 2. Okay, that means the coefficient in front of PF got changed to -2. And so you can look through there, and I think the handout asks you to look at each one of the cells that is a formula. The B matrix also has a formula. So if you look here, it says these 2 cells, remember the equation 1 and equation 2 are the ones that have the expansion terms or the shock variable of Q prime on the right hand side, and so they're both equal to 1 because that's the fixed assumption we're going to use on the percentage change in output. So all of our experiments are technically going to be the change in prices from a 1% change in output. Okay, a 1% shock to the ag output market. But what we're really interested in is looking at a few things of interest here. And so let's, the last piece here, I guess I should show you, is this is actually the solution listing right here uses the formulas for matrix multiplication and matrix inversion. So if you look on the inside of this, guess it's easier to see if I do it this way. If you look at the inside here, the blue cells with the M inverse, it says first let's invert this matrix, right? The A matrix. So that gets inverted, and then it gets multiplied by, if you step outside of those inside brackets, then let's multiply it by this matrix, J3 to J9. Okay? And so we get first an inversion and then multiply that inverted matrix times the B matrix, and we get our solution. So it's a very compact way of getting our results. And again, this should all be built for you. I want you to focus on some of the sensitivity issues. So the experiments 1 and 2 that we'll look at in just a second. A couple things to look at here. We could have kept playing with this and solving this algebraically. Okay, so once we made our two assumptions, the model actually gets pretty easy to substitute and keep working with just algebraically, and if you want to do it, go for it. But here are the results you would find. First of all, you would find that the change in the output price divided by the change in the land input price, right? Remember, only one input price gets to change here, and that's the land price. Okay, the non-land input is a fixed price part. This cell right here is always going to be 0, just like these two cells on the land supply and land demand are always going to be 0. That's part of our assumptions. So when we set this up and solve it, we will find that the ratio of the output price to the input price changes is always 0.25, or sorry, it's not always 0.25, it's always equal to the land cost share. Okay, so how is the output price going to adjust compared to the input price? Well, that's a fairly simple relationship, because only one input price is allowed to change, and it makes up 25% of the cost of production. Okay, or whatever percentage it makes. So if you see this and you want to change it, this assumption to, let's say, 0.10, you see that relationship just changed to 0.1. Okay, so this value right here, this relationship between the output price and the input price under the assumptions we built, is exactly equal to the cost share. Let's change it back to our fixed assumption. The second one that's kind of interesting is that the shock level divided by, so the output shock that we have divided by the change in demand for the non-land input here. So this is, I guess, Q prime, sort of, yeah. So it's Q prime divided by X dn, if you like, is another way of thinking of that. So the shock right here divided by X dn from right there is 0.75, and that's always going to be equal to this share. Okay, so whatever the non-land cost share is going to determine this value. So how much bigger does the quantity adjustment of the non-land input have to be? Well, it depends on the cost share. Okay, so if we change this to 0.4, we see that changes to 0.4, that changes to 0.6. Doesn't matter what the substitution elasticity is, those cost shares are going to drive it because of this assumption where we fix the quantity and we fix the price here. Okay. Okay, so when I said we were making these assumptions to get some known results, those are the known results. That's a way to build this model out and test it to make sure it works. And if we get around to building the 9-equation version with all the details, we would set it up to solve this one first, because we need to make sure we can get these known results. But anyway, so you see here what we have. The ratio of the output price to the input price that's changing depends on this cost share. the ratio of the output to the input quantity that's changing depends on this cost share. So it's kind of a interesting thing that holds up. Okay, let's jump back. I think that covers it. So what you're going to be focusing on really are the land price changes that come from your model. Let me set this back to the base value. The land price changes, I think, are the interest, or because these are related, right, by the cost share. We already know kind of how they relate to one another. So really, we're just looking at how do substitution changes cause the land price to change. Okay, and so we get experiment 1. Basically, I ask you to use the base assumption for all values. That means the way the spreadsheet is when you open it. Test the following values. You can pay attention to the impact on land prices, ag output prices, and non-land input demand. So how does the land price, the ag output price, and the demand for non-land inputs change? The relevant question you want to think about is how do 1, 2, and 3, those 3 components, respond to increasing substitution for non-land, between non-land and land inputs. So we're making an agricultural output. Land is sort of an essential input, but we can replace it to some degree. We can replace it with chemicals. We can replace it with row spacing that's more efficient. Several things, right, that might be able to boost boost output on the same land base. So why do these impacts occur when the substitution possibilities adjust? So that's some of the things I would talk about. So the first step, I'll do a couple of these with you, is 0, and I'll do the first one, the second one, and the last one here just to show you. So it says the first step is to try 0 for the substitution elasticity, and you see it fails. Well, that should make sense to you, because if you can't substitute for land at all, there's no way to raise the output level. Okay, so you need to have some substitution possibility. Otherwise, there's no way to raise the output level if land is required on a per unit basis. So that's the fixed proportion assumption. So if we adjust it just a little bit, you'll start to get solutions. They'll be big, right? Do something like that, and so you'll see here, if the substitution is very, very small, then what do you get? Well, it becomes very expensive to stay in this market because land rents go up by 133%. Ag output prices get very expensive, and to the level that if we had a demand response in this model, we had the ag output market, you would think that that would kill off the demand shock. So people want more ag output, and if it becomes the case that there are no substitution possibilities with land, and land is in fixed supply, then prices get so high that you would think it would push back the demand response. We don't have that. We have a fixed shock for the demand here, and so you can see we get these very large results. 0.1 is still pretty small. Talking about a 1% ag output change giving us a 13% change in a 13% change in input prices. There are lots of people who would tell you that's about right, that a substitution elasticity of 0.1 or smaller is about all you can get, right? Because it is difficult to substitute for land at some level, because especially in a country like the United States, ag production is fairly efficient. We are not wasting much, and so the ability to kick up output just by the way changing the way we produce and trying to substitute machinery or labor can be very difficult, and that's why demand shocks filter through and give us these land rental rate changes. Let's think about what if it was really large. I think the last value was 100. Well, as you might expect, If it's very easy to substitute between land and non-land, the price changes go to something very small, a hundredth of a percent. Um, you still require more land, or sorry, you substitute this in. It has very small price impact because you just replace out the land with non-land inputs. Okay, and so that's the sort of path I want you to look at there in experiment 1, and then let's move to experiment 2. Basically says take the basic assumption back to 1, the substitution elasticity to 1, test the values below for the land cost share. So now we're going to make different assumptions on the land cost share. That will cause the adjustment to happen automatically for the non-land. So 0.1, 0.3, 0.5, 0.7, 0.9. So we'll just do the first and last of those and look at those and get an idea. So we've got the substitution elasticity fixed at 1. So what we're looking for now is what kind of things, how do these adjust? How do the land prices adjust when land is a relatively low cost of production? 1% change in output gives us a 1.11% change in the land price. When it's quite high, something that's very land intensive in its costs, 1% change in the ag output, 10% change in the land cost. And so that's what we get. So you can trace that out, and obviously what you're going to see is it's going to get sorry, let me check it. Yeah, so you're going to see it grow slowly and then shoot up, I believe, if I remember how this works. Yeah, so it goes from 1.11, and at 0.5 it goes to 2. And so what's going on here, the takeaway is, even if you have high substitutability between land and non-land, if land is a very high cost share, right, it's already a big part of the production, then it's hard to adjust away from it. And so you end up having a sort of a net substitution process that is fairly small. It's hard to shift away from something that's very dominant in the cost share. Okay, if land is required at 90% of the costs, then it's hard to adjust away from it. Okay, and so that's really the part that we're trying to deal with. So it's I guess the two experiments, the purpose of those is to give you an idea that the substitution elasticity has a role to play. It tells you sort of how, we'll talk about this in class, how the isoquant is curved, how easy it is to make trade-offs between, in general, how easy it is to make trade-offs between land and non-land. These cost shares tell you sort of what the base production, what the optimal market ratio is between the two goods, and they can also make it harder to substitute. Okay, so if you are already committed to a production plan, an optimal point in the economy where lots of land is used, low intensity, think of developing countries where there's sort of land abundance, maybe some cheap labor that doesn't cost much, and they go out and produce in that fashion. So land is sort of the scarce and expensive input, and it maintains a high cost share. Then it's hard to adjust away from it. It's hard to ag output demand changes cause the land price to move up fast, because the substitution, even though it would be simple to bring in machinery and adjust, the equilibrium point does not, in the market, does not point to that. Okay, so I think there might be one additional thing in the slides that I mentioned I was going to do. How good are the assumptions? These are fairly common assumptions. So if somebody just wants to sort of trace out the potential for a shock in agriculture, these are sort of what they do. Land supply is very inelastic. It's costly to convert existing lands, that aren't used for agriculture into agriculture. And so the second part of it, and so that's why, being something that's very inelastic, we use the extreme value of not letting the land quantity adjust, but for it to be very inelastic would be an appropriate value. Agriculture is small as a piece of the economy, and so that means that agriculture can have big shocks and need more chemicals and need more fuel and need more labor to be brought in to meet the additional demand, but they won't move the price. The market price won't be affected much because agriculture is a fairly small piece of GDP. And so when you talk about competing for sort of factory space to produce chemicals off of chemical control of weeds or fuel production, agriculture is quite small, and it doesn't have this big demand effect that would cause the price to rise. And so that's why we say that it's a fixed price for the non-land inputs. So we use the most extreme version of those to sharpen our focus on the substitution role, but but they're only extreme in the sense that they're not that they let us isolate the substitution effects. The true values would be something close, very high, very high supply elasticity for non-ag inputs, for non-land inputs, and very low supply elasticity for land supply. We should look at a couple other things. So what does it look like to change maybe the high cost share of land and low cost share of land? How do the substitution patterns adjust? So two things matter: how substitutable are the inputs, and how much of the cost gets tied up in an input. And so we could do that. I guess the last thing I'll show you here is maybe making a data table, I guess, would be good. So let's just look at the land price. And so to make this data table, you can type equals to the cell for the land price. Okay, so it basically just copies over, let's move it down here. So let's put the land price right here. So we'll go equals cell L5, and then what you want to do is make a column underneath this and a row to the side of this that measure different assumptions for the land cost share and the substitution elasticity. So I'm going to put the substitution elasticity down here, maybe at, I think this will probably work. So that looks okay. And then maybe here we'll put 0.1, 0.5, 0.9. And so up in, I'm going to center all of these. Okay. And so now what we want to do is, this means that underneath this column will be the results for the land price. Underneath this column will be results for the land price when the assumption of land cost being 10% of total costs. We'll have all those results under here for different substitution elasticities. And then we could compare those to this one where it's a high cost. That wasn't what I wanted. Okay, and so the way to set this up is, I believe, we highlight all the cells, and this corner cell is the thing that's going to sort of pivot or build this table for us. And if you go to data and you go to what if analysis here and choose data table, then it gives you this little box that says, what do you want, what are the rows, and then it says what are the columns. And so you can point it to a parameter of your model that controls each one of those. For the rows, we have the cost share of land. Okay, so this is going to be an assumption of 0.1, 0.5, or 0.9 for the cost share of land. And then for the column, it's going to be the substitution level. So it's going to point to that cell. And so what Excel will do is it'll go through and it'll cycle through our equations, and it'll solve for this land price under the assumption of sigma 0.5 and cost share 0.1, sigma 0.5 and cost share 0.5. And if everything works out, we'll see the results here. Yeah. What am I doing? Number. Okay. All right. So what you see, as we expect, as substitution goes up, as substitution goes up, moving down, for the low cost share, you end up with these very small impacts on the price. But when land is a high cost share, you get something quite a bit larger. And so, and then in the middle, you get something not exactly in the middle, right? So as this cost share goes up, this thing gets steeper and steeper. So you can see it's moving from 2.2 to move it up by 0.4. The cost share moves from very small to a middle value, and this about doubles, but increase it by that same amount again to a very high concentration, right? So a lot of the costs are tied up in land. Then the land price effect is very strong, and in fact it's very strong all the way down here, right? So look at these. Remember, everything is a 1% shock to output. So it doesn't take long moving down these two columns until the price shock in land is smaller than the actual output shock. So we're talking about output goes up by 1%, land prices go up by less than 1% under this assumption, right? And everything below, or under this combined assumption. But if it's this high, if the cost share is that high, then if we move down, 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 we still don't get underneath 1. And that might be a useful benchmark. So that's something to play with. You could do a much bigger table if you wanted to look at more things, but that's just kind of an extra piece that could be evaluated. With that, I'm going to cut off the video and start working on your quiz. Your quiz will just be a few directed experiments where you have to report a result, but also a couple of questions from the handout. So that's the end of Lab 8.